They say boys don't cry, but your dad has shed a lot of tears. They say I should be a strong man, but baby, I'm still filled with fear. Sometimes I don't know who I am. Sometimes I question why I'm here. I just wanna be a good dad. Will I be? I have no idea. They say girls shouldn't be tough, and mom should raise the kids at home. But baby, I know that isn't true, cause your mama's the toughest person I know.
Hey class, welcome to another episode of Bran Academy. As always, my name is Bran. I'm Mr. Wynn's twin brother. And today, we'll be talking about chapter 11-5, areas of similar figures, okay? So again, we're talking about areas and similar figures. Okay, it's a little throwback with similar figures, right? It means same shape, but not necessarily the same size, okay? Not necessarily the same size. You don't have to write that part. Just a throwback. Alright, so here's a little investigation here, okay? I'm going to speed through this. So, for part 1 here, you have 2 squares, okay? We're going to compare these two. One square has a side length of 2, the other has a side length of 4. Okay, so what's the scale factor? Simplify 1 to 2. Areas of figures. So the area of this, okay? Area of a square is base times height. Let's just say, let's call this 1 and 2 here. For the first square, it's going to be 2 times 2, boom, boom, 4. For the second square, 4 times 4, 16, okay? Based on their lengths here. So the next question here for the fourth column is ratio of the areas from small to large. We're going to have 4 to 16. Simplify 1 to 4, okay? Next up, 2 equilateral triangles. Length 4 and length 12. Let's see here. 4 to 12, 1 to 3, okay? And then area of a triangle, area equals 1/2 base times height. Ooh, okay, well we know one of the side lengths is 4 here. So what? I'm gonna do my work up here a bit. I'll probably do it down here. You draw a triangle real quick. Boom, boom. It is an equilateral triangle, so that's kind of cool. That's good to know. Because if it's equilateral, you do know that each angle is 60-60. Hopefully something pops up in your head thinking, oh, it's 60-60. Well, you have to do 30-60-90 right triangle then, right? Boom, it's right triangle. Let's say this side here was 4. So if that side is 4, this here means that the opposite to 30 is going to be 2. And then opposite to 60 is going to be 2 radical 3. And if you forgot how I got to that, just remember your ratio 30, 60, 90, x radical 3, 2x, right? Given the 4 first, right? You're given the 4 first. Solving for the x, it would be 2, right? So that's how I knew opposite to 30 is 2. Over here would be 2 radical 3. So now you know the height. Okay, this is the height. The height of a triangle is 2 radical 3 for the first one there. So in this case, for the first triangle, area equals 1/2. My base is, well, that's 2, that's 2. Okay, that's going to be 4. Base is 4, because all sides of a triangle would have to be 4 anyways, since it's an equilateral. The height is 2 radical 3. You can just cancel out the 2's here. So it would be 4 radical 3. And just to save some time, because this isn't the main part of the lesson, the area of the second triangle is going to be 1/2 the base, which is 12. The height, which you use the same method here to find the height. In this case, I'll just give it to you. The height is 6 radical 3. The 2 and the 12 will cancel out to a 6. This is 36 radical 3. So setting this up as your ratio, you have 4 radical 3 to 36 radical 3. This was simplified to, well, honestly, the radical 3's can just cancel out, right? Boom. 1 to 9. Bam. Okay, lastly, parallelogram. One of them have base of 3, height of 2. Honestly, you can just pick one to compare for the scale factor. You can go 3 to 12. Or you could go 2 to 8, compare the heights. In the end, it doesn't matter. They're both going to be 1 to 4. Okay. Area of a parallelogram. Remember that index card that we made into a rectangle and cut it up? The area is still the same, base times height. For the first parallelogram, it's going to be simply 3 times 2, which is 6. Area of the second, 12 times 8, which is 96. The ratio, 6 to 96, 1 to 16. Okay. So that's cool. Okay, it's just a little investigation here. We're going to come to a conclusion. So let's see right here. Do you see a relationship between the scale factor and the ratio of the areas? So let's compare. Scale factor, ratio of the areas. Scale factor, ratio of the areas. Scale factor, ratio of the areas. Okay, try to think about this. Think about this. Turns out the scale factor will always be squared to the ratio of the areas, right? To get to your scale factor, you have to square it. Sorry, to get to the ratio of the area, you square your scale factor. Okay, so for example, I guess here's a little formula. A over B is your scale factor. I put SF for scale factor. And I'm going to put RA for ratio of your areas. RA would equal A squared over B squared. Right? So if I wanted to go from here to here, you would square it. Okay, you square your scale factor to get your ratio of the areas. If I wanted to go backwards, okay, here's a fun twist. If I want to go from the ratio of the area to the scale factor, I would take the square root. Okay, those are its opposite operation. All right. So the theorem here that we just discovered, if two polygons are similar, then the areas are proportional to the squared of the scale factor. Okay, boom. Okay, so let's see how can we apply this to an actual problem in our class or in Mr. Wynn's class. So you have triangle JKL is similar to triangle RQP. RQP, boom. And then you have JKL, boom. The area of JKL is 40 inches squared. 40 inches squared. Find the area of triangle PQR. Okay, so we're trying to find this area. Let's call it A2, okay? A2, area 1. So I kind of write down the steps here for you guys. Step 1, you want to use the area of a triangle to find the base. In this case, the base for this triangle is here. Area of a triangle equals 1/2 base times height. You know your area is 40. 1/2, my base is what we're trying to find. The height is 10. Get rid of the fraction, or actually you can just cancel it. This is 5. divide both sides by 5. Your b should be 8. Okay, so your base here is 8. Now what you could do for step 2 is find the scale factor. Okay, to find the scale factor, aka we'll label it k. So in this case here, now you can compare scale factor. Let's compare 8. You can compare the 8 to the 12. So 8 over 12. Scale factor will end up being 2 over 3. So now you can use the scale factor to solve for this side here. Let's call it x. Right, so 2 to 3 is the scale factor. I'm going from, this is top, this is bottom. So I'm going to do 2 over 3 equals 10 over x. Okay, do your whole little cross multiply. And x would be 15. Okay, so you can kind of check that work out. So x equals 15. So now you have all you need to solve for the area of this triangle. So you could do it by using the formula 1/2 base times height. But just for in good practice of our new lesson, you would probably want to use your area. Sorry, you want to use the ratio of the area. So let's try to find the ratio of the area. What you need to do here is you take your scale factor, right? Scale factor is 2 over 3. Well, now you need to square it. So the ratio of the area is now 4 over 9. And now what you could do is you can do 4 over 9 equals the 4 represent this 40 here. So the area for that one is 40 over A2. So then it turns out that when you cross multiply, you're going to have 4A2 equals 360. A2 would be 90. Boom. 90 inches squared. Okay. So again, a couple ways you could have done it. The new way we're learning here is once you find the scale factor, you can just square it, right? Find the scale factor, you square it. Now you have the ratio of your areas. Then you can set that into a proportion. So now when you're dealing with area, 4 over 9, this is 40, you solve for A2. Obviously, you could have done the scale factor to find the missing side, which is what we did to get x equals 15. You simply could have also just plugged it in. 1/2, my base is 12, my height is 15. Solving for this, your area of your second triangle is also going to be 90 from up here. Okay, so multiple ways. So that's mainly the notes there. We're going to do some example problems for the second video, so please go to that link.